In this section, we are going to be taking the graphs of sine and cosine and making 4 different changes to those functions. These changes are going to scale the graph that we normally have for sine and cosine. It will either stretch or shrink the graph that we have, or it will simply move it up, down, left, or right. The functions that we are going to be referring to here with the variables in mind, we have s of x is equal to a times sine of the quantity omega x minus phi plus b. We're also going to be looking at cosine, or c of x is equal to a times cosine of the quantity omega x minus phi plus b. We have 4 different variables in each of these functions that we're going to be considering here. We have the variables a and b, as well as the variables omega and phi. We're going to first start with the variables of omega and phi, which are going to demonstrate the changes we can make to the x values of this function. In this case, we are typically going to be considering that omega is greater than 0. If, for example, you have omega that is less than 0, it is typically advised instead to adjust the function using concepts of even and odd functions in order to change what you have. First, let's start off with the period. The period of both sine and cosine is typically 2 pi. However, when you make adjustments to the function, that might stretch or shrink that period. Specifically, the value that will adjust your period, the period change, is the variable omega in this case, the number that multiplies or divides your value of x. That will be your period change. However, it is not just the period itself. In order to find the new period of either sine or cosine, take the original period of sine or cosine, which is 2 pi, and divide by that number that is multiplying x. This will indicate how long it takes for the graph to complete one full cycle. Next, let's talk about the other change we can have on the x values. That is going to be the phase shift. The phase shift is also sometimes known as the horizontal shift and sometimes also known as the phase angle. Either way, however, it demonstrates how far you take the graph and you move it physically left or right from the original position. The phase shift here is calculated by taking phi divided by omega, which means it is not just the value of phi that is being subtracted from the value of omega x. In order to find the phase shift, take phi and divide it by that period change of omega. Or a very common strategy that many do when graphing these functions is to first take the inside expression within sine or cosine and factor out the value of omega, or the number that is multiplying x. If you factor omega out of that entire expression, what you will have remaining, for example, would be for a cosine would now be a times cosine of omega times the quantity x minus phi over omega. And the plus b will still be there. If you factor out omega first, that will give you your phase shift inside of the brackets. Next, let's talk about the values that influence the y-coordinates of your graph. First, the amplitude. The amplitude is calculated by taking the absolute value of the number in front of either sine or cosine, the number that is either multiplying sine or cosine or dividing sine or cosine. This will now indicate how tall the wave is from what we call the midline. The midline of your graph, as demonstrated with the image that we have on the right here, is the line that goes halfway through your curve. It is the line that the curve, you could say, is oscillating around. Typically, when we talk about either sine or cosine, the original midline sits upon the x-axis, which means the midline is y equals 0. From the x-axis, the graph of sine of x or cosine of x typically goes up to a height of 1 or down to -1. That means the amplitude, or the distance from the midline to either the peak or the trough of the curve, is 1. When you have a value that is multiplying sine or cosine, that is either going to magnify or minimize that amplitude. For example, 2 times sine of x would amplify the amplitude and make it so you go up to a height of 2 and down to a trough of -2 instead. We have here the absolute value of a is the amplitude, because when we report what the amplitude is, we never say the amplitude is a negative. The reason for that is because it is an absolute height. It is how tall it is for the function, either from the trough or from the peak. When you're measuring height, you don't indicate a negative for it, because negative indicates a direction. Height is simply an absolute measure. Lastly here, we're also going to talk about what is the vertical shift. We did the phase shift or the horizontal shift already. The vertical shift will be how much you take the graph and you move it either physically up or down some amount. And the vertical shift is represented by the constant value that is either being added or subtracted to the function of sine or cosine. If you are adding some amount, that means that you are going to vertically shift the function up that many places. Whereas if you subtract, then that means you are going to vertically shift the function down that many places.